Hi, everybody. My name is Julie Choi, and I work at Intel. I'm a VP in the AI products group. Very happy to be here today on this lovely Saturday. Thank you all for taking time out of your busy schedules to come and learn more about AI. Today, I'm going to walk through some really exciting use cases and just what we're seeing as Intel in this AI journey. First, I'd just like to introduce myself as a proud alum of MIT. Um, yeah, it's been a while since I was at MIT. It's been around 20 years. I'm class of 99, management science, course 15, for those of you that might know MIT speak. Do we have any course 15 people in the room? All right, represent. Those people are really important to know because these are the people that will likely translate the benefits of the technology that the engineers are building to the rest of the world to buy, right? One of the biggest things I learned from my MIT education was really about perseverance. You can solve anything, you just need to be able to stay up all night sometimes. My first job out of the Institute was as a hacker, so I used to be hired to obtain root into the Fortune 500, which wasn't that hard. After that, I moved to the Valley, spent most of the past 20 years here in Silicon Valley. And my day job is Intel AI marketing, but my real job is mom to two amazing children, one of whom is in the room today. Thank you for coming and joining me, son. And today, again, I'm here to talk about AI applications. And there are really three factors that are driving the explosive growth of AI today. The first is algorithmic innovation. The second is data. And the third are advances in compute. So let's walk through that quickly. Algorithmic innovation. I'm sure you've heard today from many people about this topic, but when you think about AI and the explosive innovation that we're seeing, it's really relatively a recent phenomenon, right? So only 7 years ago did we break through with Alex Krzyzewski's work with the AlexNet model. And since then, there have been a number of really amazing algorithms developed for vision and speech and sparse data. And it's really just the beginning. I think that what we're seeing is, at least at Intel, over the past 3 years that I've been there, enterprises are finally starting to be very interested in how to apply AI. It's still early days, and it's really the algorithm that's going to be at the heart of this transformation. The second factor contributing to AI application growth is, of course, data. Without data, you're not going to have algorithms, right? And so when we talk about data, a lot of times, we talk about the growth. So let's start there. Some project that by 2025, we will have around 175 zettabytes of data worldwide. Well, what is 175 zettabytes? I asked my team to help me visualize what that would look like. That is the equivalent of stacking something like 25 trillion Blu-ray discs at maximum capacity all the way from Stanford, Hoover Tower, to the moon, and taking that round trip around 23 times. It's a massive amount of data. And of course, the amount of data is a big factor in feeding deep learning algorithms, but AI algorithmic innovation is not just about amount of data, it's also about variety of data as well as velocity of data. And that's something that I learned from Professor Stonebreaker at MIT, who maybe some of you took classes with. The third factor contributing to AI growth is compute, specifically the innovations in AI hardware. This is something that I do every day. At Intel, we're working on innovations on the hardware and the full stack software that you need to enable that hardware. And our friends at OpenAI, which is one of the leading think tanks in AI, just released that the demand for AI compute, specifically for deep learning training, is doubling around every 3.5 months. That's a tremendous rate of growth, and it's a tremendous amount of demand for advances in compute. So at the end of the day, to create AI applications, you need to think about this development cycle. It's about understanding your data, being able to architect infrastructure and systems that can grapple with that data and get the insights you need out of it. And it's about creating algorithms at scale and using the right type of tools. And this is not a simple thing. It's a very complicated thing. I think that over the past 20 years of working in tech, most of the past 10 I've been working on developer tools. This is like the most interesting and difficult problem area that I've seen yet to solve. And that's what's driving a lot of the demand, right? That's why so many enterprises are willing to invest, because the payoff is so huge, and the stakes are high for problem solving. So let's talk about some of these applications. So we're going to walk through 3 application examples today of how AI is transforming the world. I do have a few more videos, and I'm hoping the sound is resolved. But my point here is that virtually every industry that you can think of is undergoing this transformation. And it's not just the number of industries, it's also the global nature of AI. AI application transformation and the potential for impact is truly a global phenomenon. So let's walk through 3 examples from around the world. We'll start in China with an example from healthcare. Specifically, we'll look at an example from the IRI Health Hospital System. So IRI hospitals are dedicated to vision and the exploration of technology to help with degenerative eye disease. And Intel partnered with IR Healthcare on an AI solution that would assist the physicians in China with delivering insights to patients that were suffering from ophthalmologic degeneration. And one thing to note about China is that the number of physicians is actually, it's deficient compared to the number of population that requires help. And so AI is incredibly useful in augmenting the physician. There will be no replacement of physicians, no robot doctors in China. It will be an augmentation. And what we see here in this particular example is, again, that application lifecycle. Here, the data was taken from 5,000 patients, and it was actually image data of the inner lining of the eye from these 5,000 patients. And this image data was used to train a model, a convolutional neural network, 26-layer SqueezeNet to be exact. And using that model that was trained, it was also inferenced in a private cloud. So the deployment of this AI was through a private cloud, and the ultimate value was delivering a solution to the physician, again, to help the physician diagnose these problems to 93% accuracy. And this is much higher because the average accuracy for a physician in the field in China is roughly 70 to 80% accuracy. So this increase from the AI is very helpful to the physician in diagnosing and treating the problems. This is happening for 30,000 clinics across China, reaching roughly 30 million patients. It's incredibly valuable. And we see these types of medical imaging AI applications in many different hospital systems around the world. This is just one example. The second example is very different. It comes from the UK, from an organization called Resonate. And I do have a video, and if it doesn't work, I'll talk us through it. But it is of Resonate's Vision Technology Director, Darren Wood. And he's going to talk about Luminate, which is the platform that Resonate has developed. It's an AI solution to transform railway transportation and logistics. Let's take a look.
Millions of journeys are taken by rail every day. A lot of freight moves by rail. It's still very important to the economy and getting people to jobs, getting people to friends and family. The challenge for railway operators is to deliver increasing capacity without being able to build new infrastructure. So increasingly it's about how you deliver more for less, and increasingly how you deliver a great customer experience by minimising delays. We're working with railway operators to see how we can use artificial intelligence to deliver a more proactive, better managed railway. Our solution is called the Luminate Digital Platform, and a core part of that is the artificial intelligence algorithms. It's trained upon 10 years of performance data on the networks and is looking to spot patterns for when things are about to improve or deteriorate so that operators can intervene and take positive action. Illuminate doesn't just look at trains being late right now. The key part that it looks at is where they're going to be in the future, in the next hour or so, and particularly looking at things around platforms and where two trains might be occupying the same platform. With Illuminate, traffic managers are able to make much better informed decisions. They have a simulation environment in which they can test out their changes, they can test them against performance and redo the forecast, so they know with confidence that those decisions are much better. We've been working with a European rail operator to trial Illuminate, and we've been seeing some very encouraging results. One example is when they had a large power outage at one of their main stations, and the following day trains were in the wrong place, and they made extensive use of Illuminate to reschedule and get back to an acceptable level of performance.
Okay. Thank you, Darren. So again, Darren is the Director of Vision Technologies at Resonate, and Resonate has created an AI platform. It's a software product that's delivering insights to railway systems across Europe. Ultimately, railway and transportation systems across Europe care most about delays. Nobody likes delays in the airport or in the train station or wherever. And so they're using the Illuminate platform to move trains around, to optimize how many trains can be on existing railways, and ultimately reduce delays and disruptions and increase customer satisfaction. And the AI equation, if you think about it in this case, the data is coming from 10 years of historical records on the movement of these railway machines. We're also getting data from real-time gateways that are installed at the track level and detecting the motions and the movements of the trains. We're also looking at maintenance and issues with trains, and ultimately creating algorithms that are predicting the delays and getting ahead of that. So it's a very interesting solution that is using on the compute side CPUs, as well as Intel distribution of Python and other tools like Math Kernel Library and other software kits to help derive the algorithm at the heart of the solution. The third and the last example today comes from North America. It's actually a hybrid. This is a company called Hubox, which is a robotics company headquartered in Houston, but also has operations in Brazil. And what Hubox is doing is it's leveraging AI to deliver independent mobility. I have a very short video that kind of tees that up. So let's watch this. Make sure the volume, tell me. Okay.
This is AI, powering the world's first face-controlled wheelchair. This is AI on Intel.
Okay. Woo! All the chips. All right, so Hubox is an incredible example of transforming lives and giving people a whole new level of mobility, right? So they have 3 applications, and one of them that we collaborated with them on is called the Wheelie, which is a wheelchair that is AI enabled. What's happening here is that people that have lost the ability to move from the neck down, and sometimes they may even have impairments in their facial expressions, have traditionally been, it's been challenging to have independent mobility. But what Hubox has done is created a system whereby we can add an AI kit that is computer vision enabled, as well as using deep learning inference on device. So it's a mini PC. So the combination of a RealSense camera and a mini PC on the wheelchair is capturing facial expression data. So the data set here are facial expressions captured from the operators of the wheelchair. And what we can produce is an algorithm that has 99.9% accuracy on 11 different facial expression types that can now be used to direct the motion of the wheelchair. It's a phenomenal application and truly transforming the lives of really 1% of the globe. 1% of the globe uses wheelchair for mobility. And this is the type of transformation that could not happen without deep learning and the data and the algorithm all working together. So I just have one last question for everyone in this room. You know, at the end of the day, there have never been as many tools, as much data, or as many problems as we have in the world. And so I would just like to ask, what are you going to transform? And I'm really looking forward to seeing what you build. Thank you so much.